So I'm trying to basically use the stuff in here to see if I can fix the VQLS issue. So that's not related to it's not related to the VQS, but the VQLS. If you remember well, there was a so I was playing with a cost function that is, instead of using the expectation value, it would use alone the overlap, the Hadamard overlap test, because then the circuit gets. I wanted to try a circuit that's simplified, so a circuit that has kind of the double amount of qubits, but it's not using all the Hadamard test and has the control inverse of the A components and all this kind of stuff. So I wanted to, but it was not working. So if I take a look at the solution from the Qiskit tutorial, and I plug it to my cost function, it still gives me a really high cost. And I'm trying to figure out what I'm doing wrong. And so this is the solution. This is the solution, right? Yeah. Should I rerun everything? Probably. Post processing. And so oh yeah, okay, because that was I think I have to remove this cell, edit delete cells. This only is there if I've executed the actual minimization, but we're not. So I'm not going to execute the minimization here. The optimization, I'm not going to execute these. These. So, okay, I don't care about the circuit right now. So false. Was false. Okay, so it's a really high cost. Okay, that's a really high cost. Now, where am I looking at? So here, there's a bit of a different post-processing, I think. The n-qubit generalization of the destructive swap test is applied to the destructive swap test. The precision measurements after applying. After applying a circuit to a quantum resistor in the state, well, the original swap test. Yeah, but I want to know a bit more about the. So is this the product, bitwise product? But if I'm not thinking, but if I do the bitwise product, Mm, because this is basically calculating the overlap. It should calculate the overlap. I'm not so sure. Because if you calculate the piecewise product, I mean, how this can't work. So if I have something in the plus state, right, and something in the plus state, so what this is doing, so what I'm currently using in the code is, which might have an implementation mistake, but what I'm currently using in the code is the notion that so you measure each pair of qubits, and then you're doing like, so this probability is 0.5 0.5 plus 0.5. So 0.5 plus 0 plus 0.5 minus 0, right? So it's plus 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 minus. And what they're saying here, it's not explained anywhere else, but didn't they have the reference? That's going to probably the reference to the same paper. Destructive swap test. Okay, just mention here. Oh, here you go. Oh no, okay, it's the same paper. Here there seems to be something. Destructive swap test. Destructive swap test. You know what? The order of input states is not relevant. The swap test should give the same result, and giving us two circuits, the result of the swap test is the non-function of the outcome. The result of the swap test is the non-function of the outcomes. Mm. Yeah, but that's what I was doing, right? It's essentially what we're doing is the none. So if both outcomes are 1, then we get a failure. Mm. But then we're talking about expectation values, or okay, this is the generalization to n qubits. See, the question is, I don't know if I have to apply this to. So what am I doing here? So I'm preparing this. I'm preparing the 3 different circuits because we're measuring 3 pairs of qubits. And then, okay, I think I might be doing this wrong. As in, like, calculating this for each of the I mean, those are exact probabilities. No, it seems to be okay, right? So it seems to. I mean, let's try one thing. Let's try one really stupid thing, which is a circuit. Let's try one stupid thing, okay? So calculate cost function of the solution. I want to try to calculate. So what does post-processing do? It returns. So you give it a circuit and it returns the overlap. So if I create a so the circuit is a quantum circuit, uh, 6 qubits, and this is basically a circuit. It's basically a kind of a Hadamard to all the qubits. Okay, and now I do test circuit draw. Okay. And so this should be. I just want to make the equivalent of, like, we just compare 2 simple things, right? And now I do we do test circuit. Okay, now we just should. I just want to get the overlap. So I just want to call post processing of the circuit, which should do the job for me to do the actual overlap test. So I'm gonna treat overlap. It's a really small overlap. Why? Maybe I'm calculating it already. So maybe what I'm doing wrong is that I'm doing these 1 minus, because I thought, so if they are the same, it should be, if they are the same, like in this case, you should have a big overlap because those things add up, right? Am I doing something wrong? Am I doing something essentially wrong? It's difficult for me to think at that point. Oh wait, why am I dividing this by 100? Okay, the counts, I'm getting the counts divided by 1,000 because it's 1,000 shots. So, so I'm getting the percentage. So it's just like, if it's 500, is like, 0.5. So those things, I think that's the problem. Those things are not needed. I don't need to do these. I think that was something that I was dragging from the previous implementation where I didn't have these divided by 1,000. Because then I was trying to just divide it by 100. So if I do that, wait a second. So I'm taking each of, so this is already gonna give me, for example, I'd say if it's 500, right? Like it's gonna give me like already the 0.5, and so I'm already operating between 0 and 1, right? Exactly. Worst case, there's just 1,000 somewhere, and so this is 1. And yeah. But something's off here, because if something's not working, like what if if they're completely, and okay, if they are completely different, you're gonna have something like that. Okay, so you're gonna get like 0. So that should work. But I would expect to get a 1, to be honest, for these. So draw output. Sorry, I wanted to print out circuit. No, because the circuits are here created. Okay. So measuring 0, 0, 3. 1. Am I measuring the right? So if I do here circ draw output VQL, things don't get printed because they're inside the. I'll make them global. Can I make them global? Probably I can make them global. Global circ1, global circ2, and global circ3. And now I should just do circ1, circ2, and circ3. And so I'm trying to print the circuit, see if I'm measuring the right things. Scrolling too much, I know. These things here don't work. And okay. So I should drawing on a separate because that's kind of overriding the other ones. Insert cell below. Circuit 1, circuit 2, and circuit 3. That makes sense. So processing. What am I doing wrong? So why is it like 0.12? Let's go verbose, okay? So verbose equals true. Okay, so the overlaps are 0.5, 0.5, 0.5. That's weird. So maybe I want to take a look at the counts. I've done this earlier. Or at how, let's say, each overlap updates. Why is it 0.5? Maybe those loops don't work well. So the overlap. So let's see how. So here we're going to do something like I want to do print. I want to print I. Print overlap 1 1. Print I. Print counts I and counts I. See what's going on. So I I want to see. Oh. No, I didn't want this. Damn it. Restart the kernel. I don't want to click on that. So, kernel ready. Let's scratch processing. And I should cell current outputs clear. Okay. Good. So we're done here, and now we're gonna execute this part in here. It's the first overlap. It's 258, 242, 253, 200. Oh, really? That's so. They're both plus. Okay. So it should be like that. What am I doing wrong in here? There's obviously something off. There shouldn't be any, like, it's an equal distribution. That's the problem. So you see, I'm getting like more or less 250 for each, and that's definitely not correct. What is the circuit doing? Oh, ouch. This doesn't add the overlap test. That's what I should do first. That's the overlap test, right? It's doing zero three one four two five and then 012. Yeah. Should apply the overlap test. Sorry. So I should do test circuit equals apply overlap test circuit. Okay. Yeah. Okay, now works. Overlap is 1. Makes sense. Okay, so the function works well. So the overlap is 1. For such a circuit. If I would do test circuit H, so homework gate, I know a Z gate, 1, 2, and I would get like an overlap that it's almost 0, right? Yeah. Okay, that makes sense. Okay, so the actual functionality there works. Now, if we so the issue might be somewhere else. Okay, so calculate cost function. So here we apply the circuit. Okay, that's the problem. I cannot add the overlaps. I should multiply the overlaps. Because if my overlap is 1, which means they are perfect, then my overlap here is 1. Then I'm going to get 2, and then 1 minus 2 is minus 1, which is... And what I want is if they are both overlaps, so maybe that's the problem. should multiply this. Could this be, let me remove these prints, these extra prints in here, because now we know this works. And let's try this with verbose false. Creating the circuit, we're using Copilla, I think, right? So I'm gonna just change these here. Yeah. Okay. It's working, it's working, it's working, it's working, it's working. Oh, but it's pretty shitty. I probably need like maybe need more iterations, like 1,000. So maybe it just needs more iterations. Yeah, it's going down. What? Where am I? Okay. So maybe I need 10,000. Maybe that's the reason it just takes longer to converge. Oh, it converges. That's not good. It goes just down to 0.78. Okay, so it's not. In this case, I'm doing something wrong in here. What if I just ignore? What if I just ignore the overlap tool for a second, and I just say, let's assume overlap 2 is always 1, okay? Yeah, that works way better. Like, this is something. So I'm getting these. So if I ignore, I'm doing something wrong with the second overlap. I don't know how to deal with it then. So it's a 3.09, 1.07, and that is, it's a bit different than this solution. So how would you do that? How do you combine the two overlaps? That's the question. How do I combine the two overlaps? Parameters. Maybe that's the idea. Maybe if it's nothing, then I shouldn't count it. Okay, it's something wrong with how I'm combining the two overlap results. Because maybe I shouldn't do it this way. Of course I shouldn't do it this way. If I think the whole idea is that if I, so maybe I'm totally wrong, but maybe I'm totally wrong. So I'm combining, so again, what was that? So it's A, X, right? And this is, so that's what I'm basically doing. So now A is like A1 plus A2, right? Okay. Maybe that's the reason I can't just do that. If one is the identity, then because then it literally means that A1, A2, the sum of those should be B. So the separate overlaps don't really help me. Maybe that's what the reason it doesn't work. I can't just calculate it like this because I'm decomposing, and so the overlaps obviously won't make sense. So if I calculate how much these overlaps would be and how much these overlaps would be, but I'm kind of optimizing each of them separately, then it just doesn't work. So my whole idea is just not working, I guess. I mean, I guess it's fine. It's a good learning, right? I can't just because the cost function here is the point here is that the way this is mathematically expressed, it already includes the fact you can add the different. So these AMs, right? So these are these my A1 and A2, right? And so by definition, you've got like those are the sums of those expectation values, and so kind of that works to calculate these, which is part of your cost function. But if I'm using the overlap, if I'm just using the overlap, then there's no way it's going to work. Because with the overlap test, okay, so what they say is that these can be calculated with the overlap test, but not the whole thing, right? Oh, no, but that's the whole thing, isn't it? How much these overlaps would be. Maybe I'm just not getting it right. So here derive the cost function by doing this extra normalization stuff, which is confusing how much these lies along B, then we can subtract from another number to get desired low number. To use a curious of normalizing the cost function, this is due to the fact that if this has a small norm, then the cost function will still be low, even if it does not agree with B. But we're just if you just calculate the overlap, why do you care What do you care about these? And then so then go ahead, and it's the sum of n, so the sum should actually work of those each components, but it's multiplied. This sophisticated way to solve these for solving these in the course called Harvard test. And for this tutorial, we'll just be using standard Hadamard test. So how much the multiplication here? Yeah, I don't know. Is this possible at all or not? Is this the multiplication the right thing of each overlap? So each component overlaps. Intuitively, it feels like it shouldn't work because I'm calculating the overlap. What I'm doing is I'm calculating the overlap of these. And this is just a sort of one of the components of the final A, right? So how would you calculate the overlap? What is these? Set expectation values, or what is these? What is this U transpose here? Like, what is this unitary? That's what's confusing me. Okay. Because pretty much stuck right now. So intuitively, that doesn't seem that it should work to me because I'm doing the overlap. That's obviously not going to overlap because it's just a component of what A is, right? But if you try to find then you have A2, and that's like and so you're trying to find an X that maximizes the overlap of each of those. That's what you're trying to do. Okay, so multiplication is definitely the way to go, but it doesn't seem optimal because addition is the wrong operation because it just we want our cost to be between 0 and 1, and so we want to minimize both overlaps. So we want to minimize the product of the overlaps. It's almost like saying, that, oh, wait a second, but if I, then maybe it makes sense that the overlap is not so low in this case. I don't know how to combine the overlaps, okay? So I'm gonna leave it here. I have to think about this. I don't know how to combine the overlaps. I think that's what's happening here. But I moved a little bit forward, so that's good. That's always good.